Hello everyone, I am Catherine, PhD student of ISER Tirupati. The title of my talk is Binary Mixtures of Colloidal Cellulose Nanocrystals and Laponite for Preparation of Functional Nanocomposites. Driven by concerns about the depleting resources and environmental hazards, researchers are now focusing on the implementation of renewable resources for the production of highly performing devices. Since cellulose nanocrystals are renewable, biodegradable and non-toxic in nature, it could replace a lot of non-biodegradable materials in industrial applications. Here in this work, we have incorporated laponite, a synthetic inorganic clay having distinct morphology, into CNC aqueous suspensions and investigated its optical and rheological properties in detail. Our system could serve as a model binary system of 1 and 2 dimensions with complex interactions. Having prepared CNC laponite binary composite system, we investigated its optical birefringence by naked eye observations. According to the literature, at lower concentrations of pristine CNC suspensions, that is at a concentration of below 3 weight percentage, it behaves entirely as an isotropic fluid. In between 4 to 6 weight percentage, it undergoes a biphasic transition from isotropic to liquid crystalline phase. At a concentration of about 12 weight percentage only, it exhibits birefringent gel behavior. Also, in the case of pure laponite suspensions, at very low concentrations, it does not exhibit any pure liquid crystalline phases. But here in our case, as we incorporated very low concentrations of laponite into 3 weight percentage of CNC suspensions, it exhibits a birefringent nature. To confirm this behavior, we have taken polarized optical microscope images, and the threaded-like structures indicates the nematic ordering taking place in these binary mixtures. This indicates that before reaching thermodynamic equilibrium, the motion of both the CNCs and laponite particles get kinetically arrested. To characterize the gelation understood from the optical observations, we performed a detailed rheological analysis. Amplitude and frequency shifts were carried out, and we could see storage modulus or G prime is about 1 order of magnitude higher than that of loss modulus or G double prime and is independent of frequency for the gel samples. And in the case of pristine CNC suspensions, loss modulus or G double prime is dominating over storage modulus, indicating the isotropic behavior. The evolution of flow curves were also investigated, and the flow curves were modeled using Kumeda model, and an adimensional parameter chi is determined. If chi turns to 1, it indicates the Newtonian behavior of suspension, and if chi is negative, it indicates solid-like dispersions. Evolution of chi is plotted with the concentration of laponite, and we could see a sign inversion taking place for the chi value indicates sol to gel transition happening in the binary mixtures. The yield stress values obtained from the Kumeda model is plotted against the concentration of laponite, and we could see as the concentration of laponite increases, there happens an increase in the yield stress values, indicating the strengthening of the gel phase. The reasons for this gelation may be due to the electrostatic interactions taking place between negatively charged CNC rods and the positively charged edges of the laponite, or due to the formation of the hydrogen bonds between the hydroxyl groups. As an application part, we also prepared thin films out of these binary mixtures. We also performed dye removal test. The dyes used were rhodamine B and Nile blue. As we soak the films in the dye solution, and as the soaking time increases, dye absorption capacity of the films increases. In the case of rhodamine B dye, the experimental data shows a good agreement with pseudo second order kinetics, indicating the mechanism of dye absorption involved is chemisorption. Similarly, in the case of Nile blue dye, the experimental data shows a good agreement with pseudo first order kinetics, indicating that the dye absorption mechanism is physisorption. We also prepared aerosols out of these binary mixtures, and the aerosols prepared by us are too light in weight that it can be placed on the top of a flower without even damaging it. We also performed a flame test on these aerosol samples, and we could see pristine CNC aerosol samples burn completely within 18 seconds. And as we incorporated laponite into CNC aerosol samples, they behave as an efficient flame retardants. To summarize, the rheological, optical and structural properties of CNC laponite composite systems have been carefully investigated. We have also prepared thin films and aerosols out of these binary mixtures. This work has been published in ACS Applied Nanomaterials. I would like to acknowledge DSC Inspire for Fellowship, Dr. Irwan Painu, our collaborator, University of Paris, France, Dr. Ravikumar Pujala, Research Supervisor, and ISER Tirupati. Thank you.